Greetings, learners. This is Ibrahim Jame MO2S. Please don't forget to subscribe, like, and share to your learning colleagues. So, this is one of the questions that I extracted from WAS, NIC, about GCE, and NICO. So, it's mostly frequently comes. So, the question reads: M varies directly as N and inversely as the square of P. Given that M equals to 3 when N equals to 2 and P equals to 1. Write down an equation connecting M, N, and P. Now, if you look at this question very well, you need to identify what kind of variation is this. It is a variation question. So you need to identify what kind of variation is this. So you can see that this is a joint variation. That is a combination of two variations, inverse and direct. I see. Now, and again, you need to be very careful. They say given that M equals to 3 when N equals to 2 and P equals to 1, write down an equation connecting M, N, and P. So if you see this kind of question, you can see that there is no other additional question. I see. The numbers are values are given. I see. There is no additional other questions that you are asked. So here, you need to write down the equation. I see. Then after writing down an equation, you find the value of the constant. I see. Using these values, the value of P, M, and N. The value of P, M, and N. I see. Now, after finding the value of the constant, you can now come and conclude that using the value of the constant to conclude that the equation connecting M, N, and N is this. I don't know whether you are getting this point. Let's solve this out. Solution. They said, as you read, you interpreter, M varies, as you read in interpreter, M varies directly as N, M varies directly as N, and inversely as the square of P. The same M varies inversely as the square of P, and the same M varies inversely as the square of P. That is P square, P to the power of 2. I see. Now, they say given that M equals to 3 when N is 2, P is 1. We are asked to write down an equation connecting. Now, let's forget about this equation connecting this. I see. Now, let's try and join this. I have distinguishes for easy understanding. I just separate. Now we join this and this. This implies M is directly proportional to N and inversely proportional to the square of P. Inversely proportional to the square of P. So this is a join of this. I see. Now let's remove the proportionality sign. Now, in removing the proportionality sign, we need to introduce a constant. You can use any variable or letter. I see. So let's use K to represent the proportionality sign. So now we said M is equals to the proportionality sign, which is K, N over P square. We have now introduced the proportionality sign, where K is the constant of the proportionality sign, of the proportionality I see, where this K is the constant of the proportionality. I see. Now, the mistake that students will do, they will now conclude that this is the equation connecting M, N, and P. This is not the equation connecting M and P. I see. You can conclude that the equation connecting M and P is this, provided that this is the values given, and there is another option additional question where you can be given m and n, then you'll be asked to find p. There you can conclude that this is the equation correct. But here there is no other additional question, I see, where you can be asked to find m when n is this or that, I see. So here, to conclude, to write an equation correctly, m, n and p, we are going to use this, I see, these values for n and p to find the constant, I see, as I said earlier. Now after finding the constant, we can now conclude using the value of the constant as what? The equation connecting m, n and p. Let me solve it out. Now let's make k the subject here, that is the constant of the proportional division from m. Oh, wow, my marker is about to finish. We said m is equals to k all over p square, I see. So now we make k the subject. To making k the subject, we have k is equals to m p square all that over n, I see. If we make k the subject, this is what we are going to have, mp square over n, I see. Now remember, they said when m is 3, n is what? 2, and p is 1. So we are going to use these values to find the value of the constant, I see. So we now substitute it there from the main one, k equals to m p square over n. So we say k is equals to, what is our m? M is 3 times, what is our p? P is 1 square times 1 square, all that over, what is our n? Our n is 2. So now this will give us k is equals to 3 times 1 square. 1 square is 1, that is 3 times 1 give us 3, all that over 2. That means k equals to 3 divided by 2 is 1.5. Now our value of the constant is 1.5, I see. The value of the constant is 1.5. Now we can now find the equation connecting m, n and p, I see. Now we move on. We said k is what? The value of the constant is 1.5. Now remember, the equation was what? M is equals to k n over p square, I see. Now we are going to substitute this to this to find our equation connecting m, n and p, I see. Now we say m is equals to, what is k? K is 1.5, times n, that is n, all that over p square. Now therefore, the equation connecting m, n and p is m is equals to 1.5 n over p square. See, this is the equation connecting m, n and p, I see. So it's not this, it's not this, provided that there is no additional question asked, I see. So we are going to conclude that the equation connecting m, n and p is m equals to 1.5 n over p square, I see. I hope you have learned. See, thanks for watching. Please don't forget to subscribe, share to your learning colleagues, let them also benefit, I see. Follow my Facebook page and also YouTube channel. Bye.